Imagine waking up in June and seeing snow on the ground. You step outside. The fields are white. The air feels like late autumn, not summer. Frost clings to the crops that should be growing tall and green. By breakfast, your family is already worried. The corn shoots look burned. The grain looks blackened. You know what that means. Less food, higher prices, and a very hard year ahead. This was not a dream. In the year 1816, people across the Northern Hemisphere lived through something like this. Historians call it the year without a summer. To understand why the world went cold, we need to go back 1 year to the Dutch East Indies on an island called Sumbawa in what is now Indonesia. On April 10, 1815, a volcano named Mount Tambora erupted. Modern volcanologists, including Clive Oppenheimer, describe it as one of the most powerful eruptions in recorded history. Scientists rate eruptions on a scale called the Volcanic Explosivity Index, or VEI. Mount Tambora reached VEI 7. That is near the top of the scale. Researchers estimate that Tambora blasted roughly 37 to 45 cubic kilometers of dense rock-equivalent material into the air. That number comes from work summarized on the Mount Tambora and Year Without a Summer pages on English Wikipedia, which collect data from geologists who studied the deposits. The explosion destroyed villages on Sumbawa and nearby islands like Lombok. Death estimates differ. Some studies, reported on the Mount Tambora page, suggest around 71,000 people died directly and indirectly from the eruption, famine, and disease. Other researchers push that number closer to 100,000 when they include more islands and later deaths. Even the lower estimate means tens of thousands of lives lost. But the eruption did not only affect Indonesia. It changed the sky over the entire planet. When Tambora erupted, it did more than throw ash into the air near the ground. It sent ash and sulfur high into the upper atmosphere. Scientists say it injected material into the stratosphere, where it could spread around the globe. That ash and sulfur formed a thin veil that wrapped around the Earth. This veil did something simple but powerful. It blocked sunlight. According to climate studies summarized on the Year Without a Summer page, global temperatures in the summer of 1816 dropped roughly 0.4 to 0.7 degrees Celsius below average, which is about 0.7 to 1 degree Fahrenheit. That might not sound like much, but on a global scale, that small average drop pushed many regions over a tipping point. The world was already cooler than usual because of two other factors. One was a long, chilly period called the Little Ice Age. The other was a time of low solar activity from about 1790 to 1830, called the Dalton Minimum. Fewer sunspots and lower solar energy meant less warmth reaching Earth. Tambora's veil of ash cut that warmth even more. By the time 1816 arrived, people in Europe and North America started to notice that something was strange. In New England, in the United States, May felt more like March. Diarists like Nicholas Bennett wrote about what they saw. In May 1816, he described how all was froze and how the hills looked barren like winter. New England Shakers, a religious community, summed it up with two simple words: weather backward. From June 6th to June 10th, reports from places like Albany, New York, and parts of Maine told of snow falling when people expected warm sun. Quebec City reported deep snow in June. These details appear in the Year Without a Summer entries on English Wikipedia and in collections of local records. Frost hit crops again and again. In New England, historians estimate that 3/4 of the corn crop failed. The New England Historical Society notes that mean loss rates for several crops were far higher than usual. Cold was only part of the story. Clouds and rain made things worse. A 2019 study led by Andrew P. Schurer, reported on phys.org, used climate models to test Tambora's impact. His team found that the eruption made an extremely cold European summer up to 100 times more likely. The same study suggested that very wet conditions became about 1.5 to 3 times more likely. Across Europe, that is exactly what people saw. In Switzerland, constant rain ruined harvests. In France, grape harvests in 1816 were among the latest on record, and in some areas grapes did not ripen at all. The French history site The Siècle explains how farmers waited and waited for sun that never came. Cold, wet weather hit farmers where it hurt most, their fields. In Ireland, poor harvests fed famine. In New England, families watched their food wither and rot. Many farmers decided they could not survive another year like this. They abandoned their land and moved west, hoping for better soil and safer weather. Food prices reacted quickly. In France, according to The Siècle, grain prices in 1816 rose about 45% compared to 1815. By 1817, grain prices were about 85% higher than in 1815. A 2-kilogram loaf of bread in Paris that cost about 60 centimes in 1815 rose to around 82 centimes in 1816 and to about 96 centimes in 1817. That is roughly a 65% jump in 2 years. In New England, oats became a symbol of the crisis. A report on PCGS.com describes how the price of a bushel of oats in some parts of New England went from around 12 cents in 1815 to about 92 cents in 1816. For many families, that meant they could not easily feed their horses, which were needed for work and travel. For ordinary people, these numbers meant hard choices. Eat less, sell animals, leave home. Some regions saw riots as hungry crowds demanded fair prices or tried to stop grain shipments. In France, the government of King Louis XVIII tried to reduce the pressure. The state and local authorities imported grain and, according to The Siècle, brought in about 1.46 million hectoliters. Officials used subsidies and controls to keep bread somewhat affordable. The Royal Society of Agriculture published a circular in August 1816 advising farmers on ways to cope with damaged crops. That circular shows that leaders understood the threat, even if their response stayed cautious. At the same time, diseases found easy targets. From 1816 to 1819, typhus spread in parts of Europe, hitting people who were already weak from hunger. In Asia, a cholera outbreak that began in Bengal grew during these years. The Year Without a Summer page connects these epidemics to the wider crisis of famine and stress. Lack of food and fear of taxes weighed heavily on people's minds. In Maine, Reverend William Fogg described the year in his own stark way. He called 1816 a time of crops cut short and a heavy load of taxes. What makes this story even more striking is that no one in 1816 knew exactly why this was happening. People looked for answers. Some blamed sunspots. Others saw the cold and storms as a sign of divine anger or the approaching end of the world. No one in Europe or New England could see the invisible veil of particles high above them, circling the globe. The true cause floated in the upper atmosphere, far beyond their reach. From our point of view today, the mainstream view among historians and climate scientists is clear. The Year Without a Summer happened mainly because of Tambора's eruption adding ash and sulfur to a world already slightly cooler from the Little Ice Age and the Dalton Minimum. Modern modeling, like the Shura study, supports this explanation for the cold. But there is an interesting twist. That same Shura research shows that some of the heavy rainfall patterns in Europe might have appeared even without volcanic forcing. In other words, the volcano made cold almost certain, and it raised the odds of wet conditions, but normal shifts in the atmosphere still played a role. This challenges a simple belief that everything in 1816 was because of Tambora alone. The eruption was the key trigger, but it worked together with natural climate swings. Another common belief is that the entire world suffered equally. Research and historical records complicate that picture. Some regions, like parts of Scandinavia, Eastern Europe, and Russia, had weather closer to normal. The Year Without a Summer page points out that the impact was uneven. New England, parts of Canada, and much of Western and Central Europe were hit especially hard, while other places escaped the worst. The story is not one flat, global disaster, but a patchwork of suffering and relative luck. Even amid the hardship, people adapted and created. Food shortages pushed farmers and officials to test new crops and methods. In Europe, the crisis encouraged more interest in potatoes and other staples that could handle cooler, wetter conditions. In France, the Royal Society of Agriculture's advice was an early sign of organized scientific thinking about farming under stress. The strange skies also left marks on art. Reports from the time describe a dry fog hanging over many areas and unusually red and yellow sunsets. Painters like J. Turner and Caspar David Friedrich, active during these years, filled canvases with dramatic, hazy, glowing skies. While not every painting can be tied directly to Tambora, researchers and art historians see links between these eerie sunsets and the mood in their work, as noted on the Year Without a Summer page. The most famous cultural echo of the Year Without a Summer came from a dark, rainy stay in Switzerland. In the summer of 1816, a group of writers, including Mary Shelley, stayed near Lake Geneva. The weather kept them indoors. Day after day, clouds, rain, and cold blocked the mountains and dimmed the light. During that gloomy stay, Mary Shelley began writing a story about a scientist and his creation, a tale of isolation, fear, and human limits. That story became Frankenstein. The Year Without a Summer page highlights this link between the strange weather and one of the most famous novels in English literature. By 1817, the worst had passed. The skies slowly cleared as volcanic particles fell out of the stratosphere. Temperatures began to rise toward normal. Harvests improved, and grain prices in Europe started to ease. Life in many places stabilized. Yet the lessons of Tambora did not vanish with the ash. For modern scientists, Tambora is a case study in how a single natural event can shake the climate and human society. Climate modelers continue to use this eruption to test how the atmosphere and oceans respond to sudden injections of aerosols. Recent modeling, reported in a 2025 Guardian article that discusses large eruptions, suggests that a tropical eruption like Tambora can reduce global wind energy potential by about 9% for 2 years. That finding connects a 19th century disaster to 21st century questions about renewable energy and climate resilience. The Year Without a Summer also shows how connected our world already was in the early 19th century. An eruption in the Dutch East Indies in April 1815 raised bread prices in Paris by 65% by 1817. It ruined corn in New England, sent families west, fed epidemics in Europe, and helped spark a horror novel on the shores of a Swiss lake. At the same time, it reminds us that nature and climate are not simple villains. The mainstream story says, volcano erupts, world cools, people suffer. The fuller picture, built from climatology, diaries, economic records, and new modeling, tells us something deeper. Tambora struck a planet already slightly chilled by the Little Ice Age and the Dalton Minimum. Weather patterns steered storms and frosts unevenly. Human choices about farming, trade, and relief decided who starved and who managed to get by. The Year Without a Summer was not only about ash in the sky, it was about fragile systems, unequal impacts, and the way one violent moment can echo through fields, markets, governments, and art. When you hear the phrase climate change, it is easy to think only of long, slow trends. The story of Tambora and 1816 shows that sudden shocks matter too. One eruption, 1 year. A global chain of hunger, fear, migration, creativity, and change. Imagine that June snow again. Then remember that behind those flakes, miles above the ground, hung a thin veil of ash from a mountain half a world away.